if y is a function of a variable u, and then this u is another function, so and u is function of gx. So it's like a chain. So what if you I just try to take another color, and so if you see y is function of u, and this function is again function of an x gx. So it's like a chain. Do you see that?
Yep.
Okay, therefore it's called chain rule. So then if you want to have dy upon dx, dy upon dx. Now if you see, if you are differentiating y, can you differentiate with x here? Y is equal to fu. Can you differentiate with x here? Yes or
No.
no?
No.
No, because there is no x. So it means you have to first differentiate with respect to u. So this would become dy upon du. Yeah, let me see that. As I said, it automatically changes sometimes. So dy upon du. But you want to have dy upon dx. And now you have u is equal to gx. So what you can, if you have y is equal to gx, can you have du upon gx, dx?
Yep.
Yeah. So it means I just take another color. So we are able to, from here, say du upon dx. We can do that, right? Because
Yep.
it's a function of something like a. So now what we would do here, we multiply this du upon dx. Once I was a student, my teacher told me that if you look at it, it's something like, just for a hint, it is something like this, that like this du and this du get cancelled and you have du upon dx. He just
Mm.
gave me this idea, or this to make it to make me understand. So I still remember it. Does it make sense to you?
Yeah, that makes sense.
Okay, so this is called a chain rule. Why? You are first doing dy upon du. So now I write here. So that so I this is one, and then you are doing a du upon dx, and then you are multiplying both of them, and then you are getting the answer. So it's like a chain. To get dy
Yeah.
upon dx, you are finding two derivatives, then multiplying them, and that gives you the original derivatives. So it's there are two, three ways of doing it. I would just do one, and then we would y is equal to u square minus 5u, right? And we are given, and I take another color instead of u is equal to 7x minus 3, right?
Yeah.
So first of all, we would do dy upon du, dy upon du. Can you help me with that?
2u minus 5.
2u minus 5, right? And now we do other, and I take the black color. What is du upon dx?
7.
Okay, good. So du upon dx is 7. And our chain rule says, so our chain rule, now I take blue color, dy upon dx is equal to dy upon du times du upon dx, right?
Yeah.
There is one hint here. Dy upon du was 2u minus 5.
Yeah.
Now you want to have the answer in x variable. And we know u is equal to what? We know u is equal to 7x minus 3. So
Yeah.
we would put it there. So I would say, I just write instead of u 2, and instead of u 7x minus 3.
Yeah.
7x minus 3. and minus 5. Why? Because our answer was 2u minus 5. So this is 2u minus 5, right?
Yeah.
And then let me then and I put this in bracket. Why? We are multiplying by du upon dx. And du upon dx is 7. It's not very complex. Yeah. So this
Yeah.
becomes 7 times 2 becomes 14. 14 into
14x.
7x minus 3. And then minus 35. 7 times 5 is 35. So is it okay?
But but the answer they got is different, so I'm not sure how
Hmm?
the answer they got is 7 and then 14x minus 11 in brackets.
Just a minute. Just a minute. 2u minus 5. 2u minus 5. Okay. And du is 7. 7. 2u should be 2u is 14x. Yeah, that's almost the same answer if I say. You can see that.
Mm.
Let's look at the answer. So, or, so 7 times 4 is 2,
28.
no, yeah, 2 and 98x, right?
Hmm.
Then 14 times 3 is 12 and 52. And this is minus 35. Yeah,
Yeah.
this becomes 98x minus 7 and 5 and 3s are 8. I think there is a little mistake somewhere. It's not 52, it is 42. So this is not, this is, you get that or you don't get that?
Not really. No, I don't get it.
I have just opened this bracket. 14 times 7 is 98. You can check it on your calculator. I
Yeah.
just did it.
All
Uh,
right.
14 times 7 is 98. So it becomes 98x. Then 14 times 3 is 42. And
Yeah.
we had already 35 from previous one.
Yeah.
Then it is 98x minus 42 minus 35 is 77.
Yeah.
And did you get this or no?
But then why is the answer different in
It's
the?
not answer is different. It's just another form. I tell you the answer. So in the book, the answer is I take another color. Uh,
Oh no, you're right. Yeah, if you open the brackets of the answer they
7
gave, it's the same
times
as what you have.
14x
Yeah.
minus 11. And if you open 7 times 14 is 98x minus 77, which is our answer also. It's just the form is different.
Yeah.
You
Makes
get
sense.
that?
Yeah.
Okay. And another way is there. Let me say that's a little tricky, but we can do that for this question also. So I just, um, what you can do, you can put this 7x minus 3 inside this equation so that you are actually the y becomes in x. That's another way. It's not a chain rule. So let me take another color and do it like that, and we would get the same answer. So what I'm saying, we had y is equal to u square minus 5u, right? And we know
Yeah.
u is 7x minus 3. So 7x minus 3 minus 5 times 7x. So we are just substituting the value of u with, you get that?
Yeah.
Okay, this is square. Uh, Can you help me with the square of 7x minus 3?
Yep. 14x minus 6x. Sorry,
No, not
14x.
14x.
No, 49x squared
49x square, yeah.
minus 6x.
No, 6x. 2 times 7 is 14, 14 times 3. Because a
Uh,
minus b square is a square minus 2ab.
minus 2ab. Oh, minus 2 times 21. Uh,
Oh,
42
42.
x.
Yeah, you are right now.
Plus 9.
42x plus 9, right? And what about opening the other? 5 times
minus
7
35x
plus,
plus 15.
now you get that 49x square. And now we try to simplify. Minus 42x and 35x becomes
Minus,
uh,
minus 77x.
minus 77x. And plus 9 plus 15 becomes
That's 26. 24.
24. So what would be dy upon dx? It would be
Okay.
49 times 2x minus 77. 49 times 2 is 98x minus 77. It's the same answer.
Yeah.
But it becomes difficult if you have a higher degree of square, higher degree polynomial. Here it was square. If it would have been, for example, raised to the power 5, u raised to the
Yeah.
power 5 minus 5, u raised to the power 4, it would become very difficult to do like this. So the example says y is equal to, you have to differentiate this. 3, that's good. 3x squared plus 4 raised to the power 5. Yeah, we
Yeah.
would do it both ways. But first we would do it like with the help of chain rule. So we say we consider let u is equal to 3x square plus 4. So if we think like this, it becomes y is equal to u to the power 5. You see that?
Yeah.
And u, we know that. So what would be dy upon du?
Uh, 5, and then in brackets 3x squared plus
No, no,
4
no, no. We are
to the
at the
power
moment just in u.
5u to the power 4.
Yeah. And now I take other color because it's already. So I would say from here du upon dx. What is du upon dx?
6x. Yeah, 6x.
Yeah, 6x, right? So what would be, I wrote it very bad, but it is dy. Yeah. Now we would say dy upon dx is equal to 5, and we would put u 3x square plus 4 raised to the power 4 times 6x. Yeah.
Yeah.
Uh, I would just write it and I would teach something else interesting. This becomes 6 times 5 is 30, 30x into 3x square plus 4 raised to the power 4. You get that?
Yep.
Okay. Now we would learn another thing, and I would take help of this example 9 again. Yeah. But before I start to do example 9 again, I would put a very simple question to you. So a very simple question. This is y is equal to, so the simple question is y is equal to x raised to the power 5. Can you help me to solve this? So what would be dy
Should
upon dx?
uh 5x to the power 4.
5x to the power
Mm.
4. Yes?
Yep.
Actually, this is an interesting thing. Actually, we are doing like this. We 5x to the power 4, and then what is left here in the bracket, if I just put a bracket here. So we took 5 down, we subtracted 1 from 5, and then we go to the bracket. Inside bracket we have x. So we say dx upon d, because, and that is 1, because d over dx of 1, which is inside the bracket. So we say 5x to the 4 is the answer. You are not taught this. If you
Yep.
are confused, just keep the question pending for maybe 5 minutes, and I would do this question which we just did with this solution. So I take red color so that So what I am saying, and I would correlate with this, the simple question which we did. So we say y is equal to 2x minus 3 raised to the power 4. So here we had x in the bracket and we have taken this 5. If it is not very clear, let me rub the 5 and put outside the bracket. Okay, so now instead of x, we have this 2x minus 3 in the bracket. You get, are you able to correlate these two questions somehow?
Yep.
Okay, now we have to find dy upon dx. D, again, I should keep the same color. So we want to do dy upon dx, right?
Yep.
So this 4 will come down like this 5 came down. Yeah.
Yep.
And then what should we do? 2x minus
2x minus
3
3
raised to the
to the
power
power of
3.
3.
Yes.
Yep.
Okay.
Yep.
Okay. And now I said whatsoever is a bracket you would differentiate. So what I'm saying, d over dx multiplied by d over dx of what is in the bracket. What is in the bracket?
2.
Not 2,
2x minus 3.
2x minus 3. Right? Now I just keep this like that, 2x minus 3 square. What is this derivative which you are taking now? Can you help me with that?
2.
Sorry?
2.
2. It's 2. Yeah?
Yep.
Okay. So this becomes what? Sorry. This becomes 8 into 2x minus 3 square. You get that? Let
Yep.
me compare with that. Oh, no, I think we changed the question. Or 2x minus 3. Yeah. So this is the question which now I think we changed the question. No worries. I would do now this like that, right? We would do this question, which is y is equal to 3x raised to the power 2 plus 4 like that again. Are you with me?
Yep.
Okay. So we have y is equal to, oh, sorry, keep on changing itself. Y is equal to, we are doing 3x square plus 4 raised to the power 5. 3x square plus 4 raised to the power 5, right? And we have to
Yep.
do, so we would now do again with that method which we did. I would write it here instead of, so that we are, so y is equal to 3x square plus 4 raised to the power 5. So we would do in this way we learn. Can you help me with that? So we would first dy
Yep.
upon dx become,
So bring 5 down.
yeah,
Then in brackets 3x squared plus 4 to the power of 4
and now we
times
put a multiplication sign, which is a dot d over dx of 3x square plus
3x
4.
squared plus 4.
So we have 5 into 3x square plus 4 raised to the power 4. What is the
Uh,
derivative of this?
6x. Yep, 6x.
6x. And now we can, so this become 5 times 6, 30x times 3x square plus 4 raised to the power 4. Yeah,
Yep.
this is, we did another way. Let's look. We previously did the same question by putting u here. We got the same answer. 30x 3x square plus 4 raised to the power 4. Here we had replaced 3x square plus 4 with u, and then we applied this. Let me go to this example like that. Let me
Yep.
let me zoom so you can compare both. So now you have this question here with the chain rule putting u, and here is the answer. And here you have the same question, example 9, alternate way. So that brings us to the next formula. If y is actually a function of fx and raised to the power n, then dy upon dx, you would bring n down, you will subtract 1, and then because this is in bracket, you would multiply d over dx of fx. Do you understand? This is the way we did here. You can compare this
Yep.
red with this example 9 alternate which we did. Let me
Yep.
bring it a little bit down. Are you able to correlate them? If not, take your time.
Yep. Yeah, I am.
Sometimes in the book, we write it in uh, condensed form. So we write instead of dy upon x, y prime, which means it's the first derivative. Yeah. And then we say, okay, and it's the same way, same formula written in another way. And then we say fx bar. Bar means first derivative. So it's the same formula.